Hi girls, here we are again. This time what we're doing is we're doing a titration question. This is a higher level question. It's 2016, a higher level paper question 1, and this is an example of a vinegar titration. Okay, so I'm only doing the calculation part here. I've done a very brief summary of titrations in sort of a vague mind map form, and I've done an easy ordinary level 1. So this is sort of the first slightly more complicated one. This is to do with vinegar. And the trick with vinegar, I suppose, is the dilution. It's all about the dilution and remembering that the vinegar was diluted and working that out at the end. So the first thing I've done is written down all the information that we need at the start, or that we're given about the vinegar, the ethanoic acid, and the sodium hydroxide. So you can see that here. Now, this is a good time, if you don't have it out already, to stop this video and get out the question 2016 and have it in front of you while we're doing this, because I haven't written the question out, obviously. I've just got the information here, but take it from me, this is what it says. Okay, so we're told that we had 18.75 centimetres cubed of ethanoic acid used, and we're given the amount of sodium hydroxide in a slightly unusual form, in that it's mass per 500 centimetre cubed, and we're told that 25 centimetres cubed of that was pipetted into a flask. Okay, so that's obviously it's not unusual, but it's slightly strange in that we're not given moles per litre. And this is quite common for higher level, where you're just expected to be pretty fluid about moles and mass and stuff like that. They won't just give you bog standard 1 mole, another mole, work it all out. You're expected to be able to manipulate mass, moles, molarity, stuff like that quite readily. Okay, so the first question, part C of this, is how many moles are in each 25 centimetre cubed portion of sodium hydroxide. Okay, so we're going to have to work that out from knowing that there's 1.2 grams in 500 centimeters cubed. So we're going to have to work out, first of all, how many grams are in 25 centimeters cubed, and then convert that to moles. Okay, so you got to be aware enough to be able to do that. So how do we do that? Easy enough. We divide 1.2 grams by 500 centimeters cubed, and we multiply by 25. And when we do that, that gives us 0.06 grams in 25 centimeters cubed. So that's the mass of sodium hydroxide that we have in 25 centimeters cubed. We now want to convert that to moles. So we go to our periodic table to find out what 1 mole of sodium hydroxide is, although you probably know this by now from doing it so often. 23 plus 16 plus 1 is 40 grams. So 1 mole of sodium hydroxide weighs 40 grams, but we only have 0.06 mole. So we divide 0.06 by 40, and that gives us 0.0015 moles of sodium hydroxide in 25 centimeters cubed. And it's always a good idea to write this out fully for yourself in an exam, because you do forget. There's numbers floating around all over the place here. So take the extra second to write moles of sodium hydroxide in 25 centimeters cubed. That's quite important. Okay, so the next thing we're asked to do is work out the concentration of the ethanoic acid, of the diluted ethanoic acid. In other words, the ethanoic acid that was used in the titration, and 18.75 centimeters cubed of that was used. That's given to you in the question. So now we're in a position to work out how much of that was used. And again, the next step that we're going to do is use our molar ratio. Now, you might remember we used a template to help us with this, so it'd be a good time to get that out too and have a look at it. I'm basically following those steps. So we're using the molar ratio. We're lucky here in that the molar ratio is 1 to 1. So the amount of moles of sodium hydroxide that was in our flask, sorry, you can't see what I'm pointing at. The amount of moles of sodium hydroxide that was in our flask is identical to the amount of moles that was in our burette. All right, and we've just worked that out. That's 0.0015 moles of ethanoic acid, and that was in 18.75 centimeters cubed. So now we're looking for how much is in 1,000 centimeters cubed. So how do we do that? Easy peasy. So it's just 0.0015 divided by 18.75 multiplied by 1,000, and that gives me 0.08 moles per litre, and that's diluted. It's important to remember that. That's the diluted vinegar. So I've managed to work out the mass in 25 centimeters cubed. I've converted that to moles using my periodic table. because they react 1 to 1, I know that the amount of moles of sodium hydroxide that I used, there, has to be the same as the amount of moles of ethanoic acid in the 18.75 centimeters cubed. So I divide that by 18.75, multiply by 1,000 to get 0.08 moles per litre of diluted vinegar. All right. Now, the next part of this question asks me about the amount of moles in the original vinegar. So what I'm going to do is work that out now. I forgot my cloth, so I'm just going to keep going with this because it's late now, and frankly I want to get it wrapped up. So what we're going to do is we're going to have a look at the next part, which is the concentration of the original vinegar. So this is part D, and we're looking for the original vinegar. So you've got to be careful here that you go back to your question and look at what exactly was the dilution. Okay, so it says in the question, again, stop the video if you don't believe me, 25 to 250. So the dilution factor there is by 10, right? And what that means is that our original vinegar out of the bottle is 10 times stronger than that 0.08 moles per litre, which is the diluted vinegar. All right? Now, it's not always a given that it's 10, so just double check that, right? Usually it's 10, it's not always 10, so just always double check. Sometimes it's 5, it could be 20. There's no rule that says it has to be 10, so double check it. But obviously in this case, if it's 0.08 molar and the dilution factor is 10, all we have to do is multiply that by 10 to get 0.8 moles per litre is the concentration of original vinegar. In other words, in the bottle of original vinegar, like that. Okay, we're nearly done. The last thing then that we need to work out is it asks us to express this in percentage WV. Okay, and it's worth remembering that percent always means that it's out of 100. And W in this case is basically, well, it's weight exactly, but it's mass really. So it's grams in 100 centimeters cubed. That's what they're asking us to find out. Okay, so it's grams in 100 centimeters cubed, like that. So what we're trying to do is work out how many grams of original vinegar. We found that it's 0.8 moles per litre, and we're now expressing that in grams per 100 centimeters cubed. Okay, so how are we going to do that? Well, obviously we need to change from moles to grams of ethanoic acid. So we go to our periodic table and we work out what 1 mole of ethanoic acid is. So we add up the atomic masses of carbon times 2, oxygen times 2, and hydrogen times 4, and that gives us 60 grams. So 1 mole of ethanoic acid is 60 grams. What's 0.8 mole, which is the concentration that we have? Well, that's easy to do. We just multiply 0.8 times 60, and we get 48 grams per litre. Okay, now it's worth remembering that 1 litre is equal to 1,000 centimetres cubed. But we're really being asked how many grams are in 100 centimetres cubed, because remember, it's percentage. Okay, so it's out of 100. So if we've got 48 grams in 1,000 centimetres cubed, how many do we have in 100? All we have to do is divide by 10. So 48 divided by 10 gives me 4.8 percentage WV. There you go. That's that one. So that's a vinegar titration. Really got to be careful there with the dilution factor. That's the important thing with vinegar. Hasn't been an acid-base titration for a while. I did mention that to you at the time. So definitely worth practicing all your acid-base titrations, okay? Particularly over the next while, okay? So I hope that helps. Any questions or any problems, let me know. I'll try and get another couple of clips up on the go in the next while, all right? Nice one. Bye-bye.